Okay, welcome to Living with Tectonic Hazards content revision series. We are looking at KQ2, right? KQ2. Okay, what landforms and associated tectonic phenomena are found at plate boundaries. So to start things off, we will be looking at macro level landforms. Now the landforms, the 6 landforms that we looked at in the KQ1 are micro level. Okay, it's like a zoom in view of what actually happens at that particular plate boundary. Now if you were to zoom out further away and look at divergent boundaries, right, there are 2 types of divergence landform that can occur. One of them is block mountains, the other are rift valleys. Now it's important to note that we are looking at divergent landforms. These are formed through divergence, through tensional force, which means that the plate is being pulled apart by the moving currents underneath. Remember when we talk about slab pull force and talk about convection currents in the mantle, right? At this point, this particular crustal plate is being pushed apart. So there's some fracturing that will occur, some faults that will occur, and these landforms will be the resultant. So if you can look carefully at this diagram I have up here, due to the tensional force that's applied by the magma below, okay, the mantle area, the thing that's undergoing the experience of the convectional currents, this plate is being pulled apart. So what will naturally occur is there will be cracks, there will be fault lines that appear due to this tension. Okay, it's like your skin, if you pull your skin hard enough across 2 sides, right, you will see a tear. Okay, now what happens is when you have this happening and the tools and you have fracturing that occurs, you may end up with the piece in the middle subducting below, okay, descending downwards and then becoming a rift valley. So this is actually how rift valleys are formed, through tensional forces. If you were to look very carefully at the diagram here, it says rift valley now occupied by a river. It is not a must that a river will occupy the rift valley, but many a times what we see in nature is this, okay, that you will find a river. Once again, it's not a must. The river is not formed because of the tensional force. Okay, the tensional force only forms fractures and the downward sliding of the midsection, which will become your rift valley. Now then, how are block mountains formed then? Block mountains are basically the parts of the areas next to the rift valley that did not subduct downwards. Okay, so they are left in place, but in relation to your rift valley, you look at the height, the elevation difference, it becomes a block mountain. So this is how block mountains and rift valleys are formed, through tensional force. Repeat, this is through tensional force. In your syllabus, you will not learn compressional force. If you were to Google, you will find explanations for block mountains that are formed as a result of compressional force. But I repeat, this is not within the GCE O-level syllabus in Singapore, so you will only need to learn the diagrams for tensional force formation of rift valleys and block mountains. Now if you want to look for the diagram, corresponding diagram for this, you can find it on page 100 of the core geography textbook. Okay, next up, let's look at volcanoes, right? So basically, you need to know how to label the various components of a volcano, right? Where will you find a crater? What happens when there's a massive eruption and the crater enlarges itself, it becomes a caldera, right? You need to be able to label and draw the cross-section of 2 types of volcanoes, right? Magma chamber, vent, your secondary cone, your main vent, your ashes and layering. These are all important. Now there are 2 types of volcanoes which you must know how what causes them and what's so special about these 2. Okay, one of them is shield volcanoes, the other one is the stratovolcano, right? Examples given here, right? The Ethiopian one, Erthal Aliyah, and Mount Pinatubo in Philippines. The more important thing in this slide here is to look at the concept of silica lava. Okay, silica content is important. Now think of silica content as in any beverage, any like hot chocolate or Milo, rare Milo that you make. So if I keep adding the powder in, okay, into the water itself, the more I add, okay, the thicker it becomes and the harder it will be to flow. So if I were to add, let's say 3 teaspoons of Milo into 500 ml of water, you get very, very diluted Milo. If I were to put in 2 kilos of Milo powder into the same 500 milliliters of water, you will get something that's akin to cake mud, right? So it will be high viscosity. Okay, when you talk about viscosity, it's talking about the thickness or the resistance to flow that that particular solution has. So we come back to my two types of volcanoes that you must know. Okay, so if you talk about shield volcanoes, why is it that they have this very wide base and low overall height? It's because when in areas where you find shield volcanoes, you have low viscosity lava because there's low silica content. Okay, shield volcanoes tend to be found at divergent plate boundaries. When you have this kind of low silica lava, it flows very readily. So you look at the first picture here is water, like pouring water onto the table, it flows very readily. Impact of this readily flowing lava is of course that it doesn't stack up. So you will have low overall height, but you will have a very broad base. Okay, the reverse is true for stratovolcanoes. It's because stratovolcanoes tend to be found near subduction areas. These are also commonly known as subduction volcanoes. Right. Also, what happens here is the silica content in the lava is very, very high, so it behaves like honey. Okay, if you pour honey out on the table, you realize it can stack up. Okay. Now the resultant landform, the stratovolcano that is formed at the end of it, will be one that is very tall. Okay, that is going to plug up the crater very quickly, and therefore build up pressure, and therefore it has a resultant impact on the type of eruption you have as well. So all these are all linked to this concept of the viscosity of the lava itself. So you have to be very clear about the type of lava and the resultant type of volcano. The rest of it, with clarity of thought, you should be. So where can you find all this information about volcanoes? You can find it from page 101 all the way to 104, shield as well as stratovolcanoes. Then if you go on to 105, you will find a map that shows you distribution of volcanoes. You must know how to describe distribution. Okay, what kind of plate boundaries are we looking at? Where are these locations? Some key terms that you need to talk about, including Pacific Ring of Fire, describing where this ring of fire is. When you talk about distribution type questions, please remember you have to talk about flow. Okay, where is it moving from the southwestern coast of South American plate? It stretches up north towards the western coast of the North American plate. So these are essential cardinal directions that you have to use. You cannot talk about it in terms of, oh, it turns left, it turns right, it goes up, it goes down. You're not a layman, you are a geography student, student geographer, so you should use suitable geographical terms. Now the plates need to be memorized. You need to know, for example, if you're talking about the Pacific Ring of Fire, what plates are involved. Okay, what kind of boundaries are there? If you're looking at the Nazca plate and the South American plate, why do you have that ring of fire there? So for volcanoes, not only must you know where they are found, you must know why they look in a particular way, because of the type of lava they have, the resultant shape, eruption type is different. Okay, so this is what you need to know for volcanoes. Now for earthquakes, right? Earthquakes, this is the content which you will find from 106 to 109. Okay, this is where you find the general content for earthquakes. You need to understand a few of the key words. What is focus? Where is epicenter? Right? What are the waves called? Seismic waves. How do they spread? And why is it that you do find these near fault lines? Okay, why earthquakes happen? Okay, extent of earthquakes, Richter scale, where it runs from 1 to more than 9. Okay, as the number gets bigger, the impact on humanity is stronger. Okay, the normal benchmark of destruction is at 4 to 5. That's where you have minor damage. The dramatic looking thing will be you start seeing cracks in walls. 4 to 5. So there are certain factors that will impact the overall impact of an earthquake happening. Okay, there are 5 of them. Okay, you can find them on page 108. Concepts including population density, right? How many people you have living in the area. If of course you have more people, the potential of more people dying is greater. Okay, level of preparedness. If your people are prepared, then the likelihood of them surviving or doing better in terms of an earthquake event is higher. Distance from epicenter, because the seismic waves do get weaker as they move further away. The soil does absorb some of these waves, So the further away you are from epicenter, the safer you are. Time of occurrence, if you are sleeping, right, and an earthquake strikes, there is very little time for you to have any sort of reaction at all. So time of occurrence do also affect the number of people who will die in an earthquake situation. Lastly, type of soil. So if the soil type in the area that you're living in is loose gravel, right, it will magnify the shaking, and therefore everything you build in the area will have a higher likelihood of being destroyed. Time of occurrence, if you are sleeping, right, and an earthquake strikes, there is very little time for you to have any sort of reaction at all. So time of occurrence do also affect the number of people who will die in an earthquake situation. Lastly, type of soil. So if the soil type in the area that you're living in is loose gravel, right, it will magnify the shaking, and therefore everything you build in the area will have a higher likelihood of being destroyed. So on page 109 of the core geography textbook, you will see a map that shows the distribution of earthquakes around the world. Now, this can also be a distribution question type, asking you to describe the distribution that you see. So the same criteria that was used for volcanic distribution applies for distribution of earthquakes as well. You do also need to mention plate boundaries, the ability to mention some of the specific plates that you've memorized, the big 9 that we talked about earlier on in KQ1. That's important. Other very important things include that you need to understand for earthquakes there is no difference between divergent, subduction, convergent or transform boundaries. As long as you have a boundary, a tectonic plate boundary near you, there's a very high chance of you experiencing an earthquake. Alright, now then what are some of these risks that we are talking about when you live near earthquake zones? Okay, tsunamis, disruption of services, landslides, destruction of properties and infrastructure, as well as loss of lives. Okay, note properties is spelled wrongly here. Please do not spell it the way I spell it here. Okay, so first and foremost, how do you trigger off a tsunami? Number one, you must have underwater earthquake where the focus and the epicenter is underwater. Okay. Secondly, you need to have uplift of the seafloor. If there is no uplift of the seafloor, there will be no tsunami. Even with uplift of the seafloor, you don't always end up with a tsunami. So if you go to page 110, there's a 5-point diagram that shows you the formation of a tsunami, right? What happens there. So you basically, very importantly, because the diagram doesn't tell you this, please remember there must be uplift of the seafloor. If there's no uplifting of the seafloor, there's no way a tsunami will be triggered. What you see in the two pictures here, before tsunami and after tsunami, this is of Banda Aceh, before the Boxing Day tsunami and after the Boxing Day tsunami in 2004. Right, so if you look at the one on top, you see all the little blue squares around. Those are the coastal buildings and the village that was in place. What has happened to them? They have all been destroyed, completely destroyed. What are some of these services that can get disrupted when an earthquake occurs? You can disrupt your electrical services, your utilities, gas pipes can get broken, fires can break out. As a result of that, if you're unfortunate enough to be driving along the roads and then one of these gigantic electric pillars collapse on you, that's it, goodbye to you. Okay, your roads can crack, fracture, you can get all these regular services can get disrupted. Landslides are another very common occurrence after an earthquake, because when you have earthquake, you have shaking of the ground. So ground that is already not compact or not held together tightly enough may, as a result, be further loosened, and then due to gravity will slide downwards and destroy whatever is in its path. Okay, so landslide is another very serious one. We don't see landslides in Singapore much because Singapore generally is a flat country. Okay, we're very, very flat. Properties and infrastructure, your houses, if not built up to standard or earthquake proofing standards, may get destroyed and you will not have a house anymore. Okay, so government have to step in, temporary housing, rebuilding of houses, insurance, and the not, right? Infrastructure, like if you look at the picture on the left, this is actually a flyover, a highway that has collapsed in the Kobe earthquake. And of course, one of the most serious effects of an earthquake is the potential of lost lives, because we live, especially in urban areas where everybody lives in a city, right? you do have a lot of things that can collapse on you when something like this happens. So if you go to page 113 of the core geog textbook, you will see a list of 8 earthquakes across from 2004 to 2011. I will not think that you will need to remember all 8 of them, but it will be good to know the 2 most serious and the 2 least serious in terms of human impact, magnitude on the Richter scale, and estimated depths. Then you can see that it doesn't necessarily mean that a higher earthquake on the Richter scale will have more lives lost or higher costs. Now, what about the other tectonic hazard that we talked about? Volcanoes, right? Are there risks of living near volcanoes? Of course there are, right? So there are 2 main risks that we will cover. First one is pollution, followed by destruction by volcanic materials. So if you take a look at this picture here, this shows the extent of the pollution that can occur after a volcanic eruption. This is a picture taken of what happened after Mount Pinatubo erupted. Okay, Mount Pinatubo erupted in the Philippines. This is what happens in the area, right? The amount of ash that drops down after the eruption on the surrounding area is massive. If you are large enough an eruption, you can cause global climate change as well. Of course, the other more direct way of getting hurt is destruction by volcanic materials. Now the lava, if you're lucky, if you meet a slow flowing lava from stratovolcanoes, right? You may be able to outrun it in a car. However, you have to note that if it's a stratovolcano, you may encounter lava bombs and other projectiles that are shot out of the eruption. So what you do see here is image from Hawaii. Right, a couple of years ago, there was a massive eruption in Hawaii of some of the older volcanoes. They were very, very slow moving lava, but because you cannot stop the lava, everything it comes in contact with is destroyed, whether it's roads, power plants, buildings, cars, or your home, crops. Everything that's in its path is destroyed. So since there are these 2 very big problems of living near volcanoes, why do people still live near them then? Okay, basically because of these 4 benefits. There are big benefits to be gleaned if you do live near volcanoes as well. Firstly, volcanic ash is very, very rich in nitrates, so it is very fertile. Basically, anything you plant on volcanic ash that has cooled down, right, it's gonna grow really fast and really well. So fertile soil, very useful for farmers. If you go to Bali, you realize that the soil in Bali is largely a very natural black soil. It's very, very fertile and very, very rich, okay, in nutrients. So fertile soil. Geothermal energy is another big benefit that you can garner from volcanic areas. So what happens here is basically you have underground water sources. They are heated up by the volcanic activity, and as a result it produces steam. So this steam is then harnessed to turn turbines, which generate electricity, and this process is geothermal energy. Geothermal energy is very green, doesn't involve the burning of anything, doesn't release carbon dioxide in the process, so it's a very good clean form of energy. Only side effect is you need to be near a volcano. So countries like Singapore, with far away from tectonic boundaries, right, have no chance at all of harnessing geothermal energy. The other one, precious stones and minerals. A lot of times during volcanic eruptions, right, precious stones and minerals are ejected from the mantle as well. So if you are in the area, right, the government actually is able to, because the government owns the area, harvest precious stones and minerals. But when you think of it very carefully, right, if you are in the area, a volcanic area, this doesn't benefit you directly because you don't own what you find. Okay, so what it does give the local people is employment opportunities. So you may, instead of being a farmer or being a jobless bum, you become a miner in the diamond mines, or become a harvester of sulfur miner, right? So you get a job instead of being unemployed, right? So these are some of the benefits. Lastly, the last final benefit that we'll talk about is, of course, tourism. Right, because there are crazy people, like you look at this tourist here, the Canadian tourist. I hope he's Canadian. He shouldn't be holding a Canadian flag if he's not Canadian, right? Who want to look at the dramatic, amazing views at the volcano itself. So they pay the extra $50 to go right up to the volcano's crater to have the up close view, right? And so tourism alone brings a lot of employment opportunities, either direct employment that's linked to tourism or indirect ones. So if you run a souvenir shop or you run a restaurant, because of an increase in tourism, your business increases as well. So there are many fringe benefits that tourism can bring to you. Once you have a volcano in your country that's active, there's a good chance that you will meet crazy tourists who want to come visit you. And with that, we've come to the conclusion of KQ2. What landforms and associated tectonic phenomena are found at plate boundaries. The related content is from page 96 to page 119 of the core job textbook. So please go back and take a quick look through the direct content in the core job textbook. Right, stay tuned for KQ3 of Living with Tectonic Hazards content revision series that will be launched soon as well. Thank you for your attention. Subscribe to the channel if you want the latest updates and notifications, and we'll see you for KQ3 soon.